Let's continue to finish off the video for the solutions for the compound inequalities worksheet. Here, let's move on to number 8. We got two different inequalities here with the OR statement in the middle. We need to solve them separately and then graph the different pieces. So let's start with the left side here. I'm going to start out by subtracting 2 from both sides, because I can. And now I got 3n less than 7n. Well, if you subtract 3n from both sides, you'll get 4n greater than 0. If you divide by 4 now, you'll have oh, sorry, I got distracted. 0 being less than n. So if n is anything bigger than 0, this inequality works. And so if we go to 0, put an open circle there. We're going to have open because it's just less than and not equal to. N is going to be any number bigger than 0, so we're going to shade that direction. Put the arrow on, and that one's ready to go. I'm now going to solve my right one here. I'm going to do that by subtracting 3n on both sides to get negative 2 greater than or equal to 1 plus n. I'm going to subtract 1 from both sides to get negative 3 greater than or equal to n. And if I really want to, I can use my reflexive property to switch on what's on what side. And I have this n is less than or equal to negative 3. So to graph that, I'm going to go to negative 3, put a circle there. I'm going to fill in because it says less than or equal to. And then I'm going to shade left because those are where the numbers are that are less than negative 3. And that's my solution space. All those to the left of negative 3 and to the right of 0. If you move on to 9, this one is a AND inequality, and it has the piece in the middle, the pieces on the side, but I can't solve them all at once because these side ones have this B term with them, and so I wouldn't be doing the same steps for both inequalities, and so I need to separate them and do them separately. So I'm going to do the left one now. I'm going to subtract 2b from both sides to get 7 less than 8b minus 9. I'm going to add 9 to both sides to get 16 less than 8b. Now I'm going to divide by 8 on both sides to get 2 less than b. So to graph that, I'm going to go to put an open circle because it doesn't say or equal to at that part. And b, 2 is less than b, which means b would have to be all the numbers bigger than that. And now we're going to solve our right inequality here. Let's start with subtracting 6. Oh, I was missing a piece here. There's a 10b that goes right there. Yeah, don't forget to copy the whole thing. I'm now going to, actually I'm going to do it differently now. I'm going to subtract 7b from both sides to get 3b minus 9 less than or equal to 6. That should be a 6. And now I'm going to add 9 to both sides. I'm going to get 3b less than or equal to 15. And then divide by 3 on both sides to get b less than or equal to 5. So if you go to 5 and put a circle there, and then you have to fill it in because this says or equal to, we're going to shade left, which is in this section. And I want both of these things to be true. So I only want the numbers that are bigger than 2 and less than or equal to 5. That's only these ones here in the middle, so that's where my solution space is. Moving on to 10. Two inequalities. It's an OR statement. Solve them separately, graph them both, and then you'll see where your solution space is. I'm going to start by subtracting 5v from both sides to get negative v plus 8. That should be plus 8 less than 7. Let's subtract 8 from both sides to get negative v less than negative 1. If I divide both sides by negative 1, I'll have v greater than 1. Remember to switch the direction of your inequality if you multiply divide by a negative. And now we got that part. Let's do the other one before we start graphing. On this one, let's add 10 to both sides to get 3v less than 3v plus 15. I'm not going to subtract 3b from both sides to get 0 less than 15. Alright, so we have a really interesting answer here. It says 0 less than 15. Is that true? Yes. It'll always be true. So really, whatever number you decide to put in for v, it will not change the trueness of this inequality. And so this one would include all numbers. If you try to graph it, you basically just shade over the entire number line. And since we have an OR statement, if something satisfies that, which every real number does, every real number is going to be part of our solution. So this one is also all real numbers for our answer there. Moving on to the last 4, right? Oh, crap, we have 6 more. Okay. Next one. You gotta do these separate inequalities. It has an OR statement in the middle. Do them separately, graph them both. You'll be good to go. Let's add 9x to both sides on this one. And here we'll have 7 greater than 6 plus x. And we'll subtract 6 from both sides to get 1 greater than x, which means x is less than 1. I'm going to solve this right one now. Let's subtract 6x from both sides to get 9 greater than x minus 1, and add 1 to both sides to get 10 greater than x, or in other words, x is less than 10. So now we can graph both of these, x being less than 1. Let's go to, where'd my 1 go? There apparently is no 1 on this graph here. Let's do the other one. X less than 10. So let's go to 10. And we'll graph to the left because we want something less than 10. It's going to be that way. And if we were to graph this guy, I want you to just think about what's going on here. Let's say we went over here and here was 1 and we drew our circle and we shaded left. That entire area that we shaded with this side would also be the same area that was shaded by that one. And so our answers are really basically this guy, because we have an OR statement and we want either one to happen. The one on the right is just more powerful, includes more numbers. Next one, number 12. So this one is an AND statement. It has a expression in the middle, inequality signs on either side. And on the front side of the assignment, I was able to solve this entire thing all in one go, but since these side expressions have a b in them, they're going to have different steps for each inequality, so I'm going to do them separately. So I'm going to do the left one. We'll start with adding 4 to both sides to get 2b less than 14 plus b. Let's subtract b from both sides to get b less than 14. And on the right side, let's subtract 10 from both sides to get b less than 3b. And let's subtract b from both sides to get 0 less than 2b, and divide both sides by 2 to get 0, 0 less than b. And so here now we have two different inequalities. Let's graph the left one. Let's go to 14, open circle because it says less than, and we're going to be shading left. And then we'll graph this right one, go to 0, open circle again because it's not equal to. And in this one, b is greater than 0, so it's going to go this way. And so since we're going from the left on the right guy, and we're going right from the left end there, we have this shaded region in the middle that satisfies both inequalities, that satisfies the AND statement. And moving on to 13, similar story just like the last one. I have to do them separately because these side ones have an x term with them. I'm now going to, on the left side, I'm just going to start with subtracting 3x on both sides to get 7 less than 2. Think about that really quickly. Is 7 ever less than 2? No. So this part here would have no solutions. And if you look at our AND statement, in order for something to be a answer to this inequality or compound inequality, it has to satisfy both the left side and the right side things. Well, nothing satisfies the left side, and so we really have no solution at all for the whole thing. Moving on to 14. Again, I'm going to split it. We have an AND statement on this one already figured out for us. Let's do subtract 5 on both sides for our left inequality to get 7 plus 2x greater than 3. We'll subtract 7 from both sides to get 2x greater than negative 4. Divide by 2 on both sides to get x greater than negative 2. And we'll solve our right one by subtracting 5x on both sides and to get 1 plus x less than 7. And we'll subtract 1 from both sides to get x less than 6. So now we have our two inequalities. We have an AND statement, which means we need to graph them both and see where they overlap or where the numbers that are between them. So let's put a circle at negative 2. It's not going to be filled in because it's less than but not equal to. And we'll put a circle at 6. Also not filled in because it doesn't say or equal to. And we want x to be greater than negative 2 and less than 6. So it's going to be this in-between region here. Those are the only numbers that satisfy both of the inequalities. Moving on to 15. This is a lot like 13, 12, those ones, where I have a compound inequality, which I need to write into separate inequalities so I can solve them separately. So here I'm going to subtract 3k from both sides to get negative 3 less than or equal to k plus 10. And now I'm going to subtract 10 on both sides to get negative 13 less than or equal to k. That's going to be my answer for that one. And on the right side, I want to get k by itself on one side. So let's subtract k from the right and on the left to get 3k plus 10 less than negative 8. And we'll subtract 10 from both sides to get 3k less than negative 18. And divide both sides by 3 to get k less than negative 6. So we need to get something that satisfies both of those. So let's graph them both. Let's do the left one first. Let's go to negative 13. I'm going to put a circle there. I'm going to fill it in because it says or equal to. And k is the numbers that are bigger than that. So that's going to be that direction there. I'm going to graph my right one. Let's get started. K is less than negative 6. Just less than, but not equal to. So I'm going to keep it open. And I'm going to shade left on that one. So I have to shade left. And the region that satisfies both of the inequalities, the AND part, is going to be in the middle between negative 13 and negative 6. Moving on to 16, our last problem of this assignment. I'm going to solve each of these inequalities separately and then graph them and see what we get. Let's start by subtracting a from both sides to get 2 less than or equal to 4 plus a. And we'll subtract 4 from both sides to get negative 2 less than or equal to a. Or in other words, a is greater than or equal to negative 2. And on the right side, I'm going to start by, I'm going to add 10a to both sides to get 9 less than or equal to 11a plus 9. And now I'm going to subtract 9 from both sides to get 0 less than or equal to 11a. And if I divide both sides by, not 10, but 11, I'll get 0 less than or equal to a, or in other words, a is greater than or equal to 0. So now if I put a circle at both these numbers, negative 2, and at 0, and I can fill them both in because it says or equal to on both my inequalities. I need the a numbers to be bigger than negative 2, so that way. And I need a to be greater than, I need it to be or greater than 0, which is to the right. And so really on my graph here is everything to the right of -2. So a greater than -2 would be all your answers.